Day 401 of doing a LeetCode problem every day until I get a job. All right, y'all, we're back again another day, another LeetCode problem where we're doing daily LeetCode problems. And today we have question number 453, minimum moves to equal array elements. The difficulty level is medium, but don't worry because we're going to keep the solution as simple and easy to understand as possible. But before we get started, y'all, don't forget to like, comment, and subscribe. And if you need any new Apple AirPods, go ahead and check out that link in the description so you can get you some. Now let's see what the question says. Given the integer array nums of size n, return the minimum number of moves required to make all array elements equal. In one move, you can increment n minus 1 elements of the array by 1. Alright, y'all, that sounds simple enough, but let's go ahead and take a look at these examples anyway, just so we can make sure that we're doing this problem correctly. So in example 1, we have the input nums equals an array of integers 1, 2, and 3. The output is 3. Explanation says only 3 moves can be needed. Remember, each move increments 2 elements. So first, we start with this, an array of integers 1, 2, and 3. We increment this 1 and 2 by 1, right? So it says, remember, each move increments 2 elements. That's because this array is 3, so we can increment n minus 1, which will be 2 in this case. But say our array was 4. Say we had 4 elements in the array, then we would be able to increment 3 elements. Or say we had 5 elements in the array, then we'll be able to increment 4 elements. It's n minus 4. That lets us know how many elements we can increment at a time. It's not going to always be 2. It's always going to be n minus 1. So depending what n is, it'll be 1 less than n. So let's start back to where we were. So first we start with 1, 2, 3. We can increment this 1 and 2 by 1. So that will leave us with 2 and 3. Then we can increment this 2 and 3 by 1. That'll leave us with 3, 4, and 3. Then we just have to increment this 3 and this 3, which will get us to 4, 4, 4. And that took 3 moves, so our output is 3 because we were able to get all of the elements in the array equal to each other in 3 moves. So let's go ahead and take a look at example 2 where the elements are already equal and we could just return 0 because we don't have to do anything. So in example 2, we have the input nums equals an array of integers 1, 1, and 1. The output is 0 because we didn't have to do anything. We didn't have to increment any elements because all of the elements are already equal. So now that we understand the question, y'all, I hope that made sense to y'all, but let's get into the fun part, the actual solution. Solution is simple and easy to understand just as much as this problem, not that much code. And make sure y'all stick around actually, y'all, because today I have 2 solutions for y'all. So make sure y'all stick around after the first solution so y'all can catch the second solution. The second solution is simple too. So let's get into it. First thing we're going to do is we're going to initialize a counter to track the total number of moves. So this is going to hold our output, and this is going to keep count of how many moves we need. So we're going to declare a variable. We can call it count, and we can set that equal to 0 to start. Now we need to find the minimum value in the array, and we will use this to calculate how many moves are needed. So for that, we can declare a variable called min, and we can set that to equal to nums.min and put the parentheses at the end like that. Now it's time to loop through each element in the array. So we're going to say for I and 0 dot dot less than nums dot count, and then we're going to open up the brackets. So in one move, we can increment n minus 1 elements by 1, right? So in this case, we can increment 2 elements in one move. So mathematically, this is equivalent to reducing all of the elements to the minimum value. So the number of moves needed for each element is the element minus the minimum value. And then we add that number to the total number of moves, or we add that to our count. So for that, we could just say count equals, or excuse me, plus equals nums square bracket I, and then we could just subtract that by min, and then we are going to force unwrap it with the exclamation point like that. Then after looping through all of the elements, we could just return the total number of moves. So we could just come right here and we could say return count, just like that. That's the whole code, y'all. It's that simple. So let's go ahead and run it. This is where you really need to know your math, because you might not know that uh just oh sorry y'all, this should be men with one I, not two. But you might not know that uh it's equivalent to reducing all of the elements by the minimum value. So, and then just adding that to the count. That's important to know. It's a little math trick. And look at this, y'all. It's accepted. So let's go ahead and submit it. See what happens after we submit it. Let's see. Let's see. Ooh, look at that, y'all. 0 milliseconds beats 100% of users with Swift. Those are the numbers I love to see. I hope y'all love to see those numbers as well. So now that we've got done with this first solution, let's get into the second solution, y'all. And guess what? Guess what? We got a one-liner. That's right, y'all. We really could solve this problem in one line of code. Let me just go back so y'all could see the question as we write the code. But yeah, it's that simple. One line, just like that. All we have to do is say nums dot. Oh, sorry, y'all. Say nums dot reduce. Open up the parentheses. We're gonna say 0, and then we're gonna say a plus. So what this is going to do is this plus means we're going to add all of the elements in the array together, and we're going to start from 0. So that's just for when we add them all together. So we're going to start from 0, and then we're going to add all the numbers together in the array. Then we're going to take that, we're going to say minus nums dot min again, exclamation point. Then this time we're going to say times nums dot count. And that's the math. You see how math works, y'all? You see how we can use math to answer these questions? So let's run it. Let's run it, see what happens. Ooh, we got an error. So let's see where our error is. Sorry, y'all. This should have some parentheses right here. Boom. So now let's run it again. See if it works this time, which it should. And it's accepted. So let's go ahead and submit it. Make sure it's still accepted after we submit it. Let's see. Ooh, look at that, y'all. Once again, 0 milliseconds beats 100% of users. Two different codes, same result, y'all. So pick whichever one you like better. I wanted to make sure I give y'all both of these solutions just because they're so easy and simple to understand. Might as well include both of them, and whichever one you like better, you can use as you continue down your LeetCode journey. So with that being said, y'all, that's all we have for today. I hope y'all learned something, and I hope to see y'all here tomorrow for another day, another LeetCode problem. See y'all then.